All right, so I am very ill. I apologize if I cough a few times during these recordings, but for today, while I'm not there, I wanted to give you some videos to watch to talk about our topic for the day, which is probability. Okay, now probability is the likelihood of an outcome happening. Okay, so like what's the probability that if I flip a coin, I get heads, right? Or what's the probability that I don't know, that if I pull a card out of a deck, I will get a jack, right? So these are some of the things we'll talk about with probability. So the result of an experiment or situation is an outcome, right? So probability is testing the likelihood of these outcomes, right? It's one individual outcome that can happen. The set of all possible outcomes in a situation is the sample space. Okay. Now, you will be asked to write out sample space to help you find probability. And so typically what you'll see with that is that when you're asked to write out sample space, you'll have something with two possibilities. What I mean by that is, let's say I asked you, write out the sample space for flipping 2 coins, right? And it landing on tails or heads, right? So there's 2 flips, and each of them can either land on tails or heads. So the sample space for that would be the first one could be tails and the second one could be heads. The first one could be heads, the second one could be tails. The first could be tails and the second could be tails. And then the first and second could both be heads. That is all the possible outcomes if I flip 2 coins, right? Just a quick tip. If I gave you like 2 coins and you have 4 outcomes, as you can see here. Now, if I said, what if you flip 3 coins, then you would have 8 outcomes, right? And I can and there's some examples of that in the note sheet, and I'll go over one of those, right? But another common one is, what if you could have a boy or a girl, right? We're going to assume the chance is equal for both of them, so you would write out like boy, girl, boy, 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 girl. Or if it was 3 children, you would write boy, boy, girl, girl, boy, girl, boy, all the possibilities, right? I think for 3 there is 8, and then 2 there is 4 outcomes. So we'll talk more about that in the notes later, but I just want to let you know about that. Okay, an event is a particular subset of the sample space, right? So let's say I said, oh, well, what if we're talking about the event of getting a heads, right? All 3 of these give me a heads, right? They're all part of this event. The only one that isn't is this one right here, right? So that's the difference between an event and an outcome. Each of these are individually outcomes, but some of them can belong to the same event, right? And then the, oh, sorry, I don't know why I blanked on that for a second. The probability. The probability of an event is the number of outcomes for an event out of the total possible outcomes, right? So, for example, quick one here, the probability of getting a heads in the example up there, well, on the bottom should always be my total number of outcomes. There's, 4 possible outcomes up there, right? How many of them give me heads? What's the number of outcomes for that event? 3 of those give me heads, so the probability is 3 over 4. Now, typically you will be able to write probability as a fraction or a decimal, right? It's kind of up to you. Sometimes fractions look nice, sometimes the decimals look really nice, but it's kind of up to you. So let's go look at this example right here. Find the probability of rolling an even number on a 6-sided die. So what are all the possible outcomes just generally of rolling a die, right? Well, we can roll a 1, a 2, a 3, a 4, or 5, or a 6. This is my sample space. If I'm just rolling 1 die once, right? These are all of the examples I can, or all of the outcomes I can have, 1, 2, 3, 4, 5, or 6. Now, what are the event outcomes, right? My event is rolling an even number. So the event outcomes would be if I got a 2, a 4, or a 6, right? That would be the event outcome, because those give me an even number. That's part of my event, right? So then what's the probability of rolling an even number? Well, it's 3 event outcomes, right? 3 of those events, or 3 of those outcomes give me the event I want, over the total number, which there's 6 sides on the die, so 6, right? This simplifies to 1 over 2. So my final answer would be 1 over 2 or 0.5. Now, there's one more thing I want to touch on before we move on, which is just some notes about probability. So probability is always a number between 0 and 1, whether that's a fraction or a decimal. So you should never have something like 1.1 or 1.2 or 30 over 10 or anything that's greater than 1 or less than 0, okay? So just make sure your answer is always that, because otherwise that's could be a sign that your answer is wrong, okay? I mentioned this previously, but probability can be expressed as a decimal fraction or percent, depends on the context. Typically, a lot of those options will be accepted regardless of the situation, but we'll talk about some situations where it matters one way or the other. The sum of all outcomes in a sample space will always equal 1. So if you were to take the probability of getting an even number on that die, that's 3 out of 6. The probability of getting an odd number on the die is 3 out of 6, right? 3 out of 6 plus 3 out of 6 is 6 over 6, right? So the sum of all the outcomes the probability of all the outcomes should be 1, right? Because you can't get something that's not in your sample space. So if you want to check if something is a valid experiment, make sure all the probabilities add up to 1, right? The probability an event does not occur is always equal to 1 minus the probability it does occur. This event is known as, we're going to call this the complement. Okay. You can denote it in some of the following ways. So you'll often see the complement of A expressed as like this A apostrophe sign. Okay. So what happens, so like, let's say I wanted to find the probability of not getting an not even number with my die, right? Well, that is going to be 1 minus the probability I do get an even die, right? Because I have two options, either get an even or I don't. Okay. So what I would do then is take the probability I just found up there, which is 1 minus 1 over 2. That's the probability of getting an even one is 1 over 2. So the complement, the probability of that not happening, is 1 minus 1 over 2, which is also 1 over 2, right? Another example would be like the probability of getting, of not getting a 1. Well, the probability of getting a 1 is 1 out of 6, because only one of the 6 dies, only one of 6 sides has a 1. So I would do 1 minus 1 over 6. The probability of not getting a 1 is 5 over 6, which makes sense because 5 out of the 6 sides on a die aren't a 1. So that's something you'll see a lot is the complement. 1, it's the probability something does not happen, which is 1 minus the probability that event A, or whatever the event is, does happen. All right? All right, so that's the first part of the note organizer. This is the next part of the note organizer. So this is kind of an extension of probability. So there's going to be some new words we're going to talk about. So the first one is union. So this is when all of the elements are in A or B. Okay? So what I mean by that is all of the components, right, of our sample space are in A or B. They don't have to be a part of both, right? And I'll get to what that means in a second, right? But the symbol you'll often see, right, for if you have two events, A or B, this isn't a U, it's a union symbol, right? It looks like a U, right? But that is to show union. Now, when you see union, you should think to add, right? So the example is like, what's the probability of getting a 1 or 2, right? So I'm not asking for you to get both, just 1 or 2, right? So I could meet event A or event B, right? That's what union means, okay? So all of the elements in my event that I want are in A or B. Intersection is all the elements are in A and B, okay? The symbol for this is an upside down U, right? And this one you want to think to multiply, right? So the probability of getting a 1 and a 2, if I were to roll a die twice, one right after the other, is 1 over 6 times 1 over 6, because each of the 1 and the 2 have a 1 over 6 possibility of getting rolled on their turn. So that would be whatever that is, 1 over 36, right? Just using that as a quick example to get you thinking, but we'll do an example over here to talk about that, okay? Two events are mutually exclusive if and only if A union B equals, this symbol means it's an empty set, meaning when we say mutually exclusive, it means there's no possibility that A and B can happen, right? So if I'm rolling a die once, there is no way I can get a 1 and a 2. It's only going to land on one side, right? So those events are mutually exclusive, okay? If I flip a coin once, I can only get a tails or a heads, not both. That is mutually exclusive. So that's what that word means, okay? Now, the probability of A union B, right, has this formula. So the probability of A union B is equal to the probability of A plus the probability of B, but then we're going to subtract the probability of A intersection B, or A and B, right, because we're talking about A or B in this case, right? So we're going to take away that part, and we just want the or part of it. So that's the probability of A union B. Now, this will make more sense when we get to Venn diagrams, why this works, but that's just, that's the formula we're going to be using for this, for a good part of this unit, okay? The probability of A intersection B, that is any outcomes that have both events A and B, right? So if you're looking for the probability of getting, if you flip 2 coins, you get 2 tails, right? If event A and event B are both flipping well, that doesn't really make sense. But basically, you're just looking for any outcomes that have both A and B in them, not one or the other, okay? Complement of event, we just talked about this, probability of an event not happening, right? So that is, again, the complement of A is equal to 1 minus the probability of A, okay? Yep, that's everything for that. Okay, I know it seems like a lot at first, but I seriously think this is, it'll start to make sense. We'll do quite a bit of practice, so don't worry too much about it. So, I have to go over this first because there are some things you need to know about cards. So we'll use cards in a lot of examples, okay? So the numbers of cards in a standard deck is 52 cards, okay? There are 2 colors of cards, as you probably know, in a deck, red and black. And there are 4 different suits: diamonds, spades, clubs, and hearts, okay? So, and they're split evenly. So, and what I mean by that is that there are 26 red cards in a deck because there's an even number of black and red. So 52 divided by 2 is 26. There's 26 red, 26 black. And there's also an even number of each suit. So if you divide 52 by the number of suits, which is 4, there is 13 of each suit, okay? Now let's list the cards in a suit of diamonds, for example, right? But this also goes for any suit. You can get a 2, a 3, a 4, a 5, a 6, a 7, an 8, a 9, a 10, a jack, a queen, a king, and an ace. A joker does not belong in a typical deck of cards, so that is not part of our probability. Okay, so list the card. These are the cards in a suit of diamonds, but also for any suit. Okay. Right. Wonderful. Okay. Now find the probability that a randomly selected card will either be red or a diamond card. Okay. Now this is kind of a weird one because obviously if a card's diamond, it will be red, but we're still going to use the formula to show how this formula is applied. Okay. So I want the probability of being red or a diamond, right? This or shows me that it's a union, so I want to use the union formula, right? The or formula, basically, okay? So that is going to be the probability of event A. So the probability of getting a red card, well, half the cards are red, half the cards are black, so my chance of getting a red card is 1/2. Okay, and what's the probability of getting a diamond card? Well, the probability of getting a diamond card is 1/4, because there are 4 of each, there is an even number of suits. There's 4 suits. There's 13 out of 52 of each, so 1/4. Okay. I also want to subtract the probability of A and B. So what's the probability of getting a red and a diamond card. Well, if I get a diamond card, it's going to be red, right? There's all diamond cards are red. So the probability of that is still 13 out of 52 because there's 13 diamonds, which again is 1 over 4. So I would minus 1 over 4. Okay? So again, this is the probability of red. This is the probability of a diamond. And this is the probability of red and diamond. Now, typically, these won't be the same, but just for this example, it is. But it's still a good representation of how the formula is used. Okay? So now we take red or diamond. We add these all together. So obviously 1/4 minus 1/4 is just 0. So really what I'll be left with is, well, let's go left to right first. So let's follow PEMDAS properly. So 1 over 2 plus 1 over 4. If I change both their denominators to 8, because that's the LCD, I get 4 over 8 plus 2 over 8. Okay? And then minus 2 over 8. What I get is 6 over 8 minus 2 over 8. That gives me 4 over 8, which is equal to 1/2. So that is the probability. Okay? We'll do more examples as in the notes, but I want to show you this example here, and then, yeah. All right. Thank you for watching.